In this lesson, I'm going to show you how to use discriminant to solve certain problems involving circles and lines. As a reminder, the discriminant is when you have a quadratic equation like this one. Sometimes you want to know what the answers are, and you factor or use quadratic formula or something like that. And sometimes they just want to know how many real solutions are there. Now, the answer is either going to be 0. It is really either going to be 0 or 2. But some people will say that the answer is 1 for certain questions because if the two roots are the same, sometimes people say it's only one root. So why don't I say how many unique? Then there could be 3 possible answers. And the reason there's 3 possible answers, if you imagine the parabola y equals x squared plus 6x plus 8, that's either going to cross the x-axis twice, not cross it at all, or just touch it and be tangent to it. Well, for this question, x squared plus 6x plus 8, or for any really, there's something called discriminant, which is b squared minus 4ac. That you'll recognize from the quadratic formula. B squared minus 4ac is the thing that's inside this radical. And if that thing, there's 3 things that could happen. If it equals 0, if it's less than 0, or if it's greater than 0. If it's greater than 0, there are 2 unique solutions because you have like the plus and the minus give us the 2 answers. If it's less than 0, they'll be imaginary, but there'll be no real solutions. And if it equals 0, in that case, the plus and minus is just plus and minus 0, so it's just negative b over 2a, so we can say it's 1 unique real solution. So for this question, since b is 6 and a is 1, b squared minus 4ac, you don't have to do the square root, just regular b squared, is 6 squared minus 4 times 1 times 8 is 36 minus 32, which is greater than 0. It means that there's 2 real solutions. Other possibilities, x squared plus 6x plus 9. That one, if you do b squared minus 4 times 8 times c, you get 0. So they would just be 1 unique. And if I had x squared plus 6x plus 10 equals 0, then b squared minus 4ac would be 36 minus 40, which would be less than 0, so it would be no real. So those are the 3 things that can happen. Sometimes on like a Regents exam, they might test your knowledge of this by giving an equation like this and say for what values of k are there 2 real solutions, or for what values of k are there no real solutions. I like the question for what values of k is there 1 unique real solution. I like that because that happens when the discriminant actually equals 0, so we get an equality instead of an inequality. B squared, if that's b and that's a, b squared minus 4ac is k squared minus 4 times 1 times 16, or k squared minus 64 equals 0, or k squared equals 64, or k equals plus or minus 8. There's actually 2 answers. This is going to become a practical question as we look at 2 questions involving circles, and here they are. Imagine I have the circle x squared plus y squared equals 20. That's a circle with center 0, 0, and a radius of square root of 20, which is between 4 and 5. And I have a line, I'll say y equals 2x, and I'm not going to tell you what the y-intercept is, I'll just say 2x plus d. So d, we don't know what it is, and we're going to solve for d. So the way there's one more piece of information. The question is, what value, or maybe more than one, of D make the line tangent to the circle? So for instance, maybe if the line's way down here, it doesn't hit it at all. But if the line's over here, it hits it twice. There's some value that makes the line hit it just once, and maybe there's a second one up here. So there's probably two answers to this question. Well, finding that question is a matter of pretending you're going to find the intersections. Like, imagine if we actually were given this and we knew what D was. The way we would find the intersection point would be by substituting for this y and the y squared this entire expression. So that's if we, in the other lesson, we knew the value of D and we substituted and solved the quadratic equation. In this case, we have x squared plus y squared equals 20 and y equals 2x plus D. And I'm going to substitute this y into here, so now that top equation becomes x squared plus parentheses 2x plus d squared equals 20. It's got a lot of variables. We've got x, x, d. Let's just see what happens. When I expand out 2x plus d squared, I get 4x squared plus 4dx plus d squared equals 20. It's getting kind of ugly. X squared plus 4x squared is 5x squared plus 4d is like the coefficient of the x, and I'm going to bring this 20 over. So I have this ugly equation with x's and d's, and it seems unsolvable, and we're not going to solve for x. We're going to solve for d using the fact that if this line really is perfectly tangent to the circle, then this equation has one unique real solution. In other words, the discriminant, capital D, equals 0. So 0 is equal to b squared minus 4ac. But b is 4d, so now it's 4d squared minus 4. A is 5. And c is a pretty complicated expression. It's d squared minus 20. So this is a pretty ugly equation also, but at least it only has the variable d in it. Continuing with this equation, I get 16d squared minus 20d squared plus 400 equals 0. This turns into 4d squared equals 400 up here. So d squared equals 100. So d could be plus or minus 10. So coming back to here, it means that this could be 10, and this one would be minus 10. Those are the two answers to that question. D either equals plus or minus 10. Those are the two values, and it's confusing because where'd the x go? Well, or how did this equation turn into this equation? Well, this discriminant equation. The discriminant for this equation had to become 0. That turned into a new equation that had no x's in it. And a very common error is to somehow get x's into that equation. Okay, the last question I want to show you is similar idea, but this time the unknown is the slope. So here I have my x squared plus y squared equals 20, and I know what the y-intercept is 6, which is up here. And of all the different slopes, some slopes won't intersect the circle at all, some slopes will hit the circle twice, and maybe there's one this way and maybe one this way where it hits the circle exactly once tangent to it. So it's the same question, what makes a tangent? And we do it the same way. We replace the y with mx plus 6. We expands, we get m squared x squared plus 12mx plus 36 equals 20. Now this part's a little tricky for people. We combine these. 1x squared plus m squared x squared is parentheses 1 plus m squared x squared. 12m is the coefficient of the x, and this becomes plus 16 equals 0. Now this equation with m's and x's has just one real solution, so the discriminant has to equal 0. And the b is 12m, so 12m parentheses squared minus 4. A is pretty involved, 1 plus m squared. That's a lot of people don't get this 1 plus m squared, and then the whole rest of the equation sort of falls apart. And c is 16. This turns into 144 m squared minus 4 minus, put the 16 and 4 together, so minus 64 minus 64 m squared. I'll bring the 64 over to the left here. Let's go to a new page. I end up with 64 equals 144 m squared minus 64 m squared, or 64 equals 80 m squared, or m squared equals 64 over 80. 8 goes into both of those, so I get 8 over 10. Reduces even more to 4/5. So m is plus or minus the square root of 4/5, if you like, 2 over radical 5, and if you like even more, rationalize the denominator, 2 root 5 over 5. So what that means, what I figured out, is that the slope of this line, if the y-intercept has to be 6, either the slope is 2 radical 5 over 5, or the slope is negative 2 root 5 over 5.